Hello everyone. Today we will going to see some practice questions from the topic electrochemistry, and this is part 4. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slide. So today we will going to see the practice questions from question number 24 to question number 31. Let's start with the question number 24. Given E0 for chromium 3 positive chromium is equals to minus 0.72 volt. E0 for Fe2 positive Fe is equals to minus 0.42 volt. The potential for the cell this is. So the reaction is the cell diagram will be chromium 3 positive, which is 0.1 molar, salt bridge Fe2 positive, which is 0.01 molar, and Fes. We have to tell the potential for this cell. Options are minus 0.339 volt, minus 0.26 volt, 0.26 volt, or 0.339 volt. You have 10 seconds to solve this question. After that, we will see the answer. Let's see the answer. So the correct answer is option C, that is 0.26 volt. So if we want to find out the E0 of cell, we just write E0 for cathode minus E0 for anode. So E0 of cathode is minus 0.42, that is this, which is represent at the right hand side of the cell diagram. So it is minus 0.42 minus of E0 of anode. So anode is this side, so it is minus 0.72. So minus of minus 0.72. Minus will become plus, and we have to basically subtract these two because here plus will come, and the final answer will be in positive because the great number is in positive term while we are subtracting these two terms. So E0 of cell is coming out as 0.30 volt. The cell reaction as per the given cell diagram is 2Cr plus 3 Fe2 positive, giving us 2Cr 3 positive plus 3 Fe. Okay, N is basically 6 here because you can see that 3 times 2 is 6, right? So 6 number of electrons are changing from here to here. So N is equals to 6 here, and we use Nernst equation, which is E cell is equals to E0 of cell minus 0.0591 divided by N, that is 6, log of oxidized state divided by reduced state, that is Cr3 positive upon Fe2 positive, and Cr3 positive whole square because 2 is a stoichiometric coefficient, Fe2 positive whole cube because 3 is the stoichiometric coefficient present in the equation. Okay, now we just put the values and solve it. So it will be 0.3 minus 0.0591 divided by 6 log 0.1 whole square upon 0.01 whole cube. On solving this log value, it is coming out as 4, and on solving this equation, we have 0.3 minus 0.04, which is equals to 0.26 volt. So this is our final answer, and thus the option C, that is 0.26 volt, is the correct answer. Okay, let's move to the next question. Question number 25. What will be the EMF for the given cell? The cell is given that platinum H2 at P1, H positive aqueous, H2 P2, platinum. Options are RT by F ln P1 by P2, RT by 2F ln P1 by P2, RT by 2F ln P2 by P1, or none of these. Basically, this is L, okay? ln. Here also it is ln. So these are the options, and you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. So the correct answer is option B, RT by 2F ln P1 by P2. So the right hand side reaction will be 2H positive plus 2 electron giving us H2, which is at partial pressure P2. And on the left hand side, this is the reaction going on, which is H2 at P1 giving us 2H positive plus 2 electron. So overall reaction will become H2 at P1 going to H2 at P2. If we write the next equation for this, it will be E is equals to E naught minus RT by NF ln P2 by P1 oxidized upon reduced. And E naught for this hydrogen electrode will be 0. It will be 0 minus RT upon N is 2, right? Because you can see here in this equation and this equation N is 2. So N will be 2F ln P2 by P1. And this minus, we just interchange this P1 and P2. We take this minus sign inside the ln value. So it will become RT by 2F ln P1 by P2. Okay, so this is the EMF final value which is coming out after calculating. And thus option B is the correct answer. Okay, let's move to the next question. Question number 26. The value of reaction quotient Q for the cell zinc 2 positive at 0.01 molar concentration, salt bridge Ag positive 1.25 molar concentration Ag is. So we have to tell the reaction quotient value, Q value for this cell. Options are 156, 125, 1.25 times 10 to the power minus 2, or 6.4 times 10 to the power minus 3. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. That is option D, 6.4 times 10 to the power minus 3. So the cell reaction going on according to the cell diagram given in the question is zinc is going to convert in zinc 2 positive plus 2 electron, and Ag positive plus electron becoming Ag. For the balancing and for the combining these two reactions, we just multiply the second reaction by 2 and add these two reactions. It will be zinc plus 2 Ag positive. 2 electron and 2 electron will cancel out, and here on the right hand side will be zinc 2 positive and 2 Ag. Okay, so reaction quotient is basically the product side divided by the reactant side, oxidized divided by reduced state basically. So it will be zinc 2 positive upon the concentration of Ag positive whole square. 2 is the coefficient because. And we have given the concentration for zinc 2 positive, that is 0.01 divided by Ag positive concentration, that is 1.25 whole square, coming out as 6.4 times 10 to the power minus 3. So Q value is coming out equal to this, and thus option D is the correct answer. Okay, let's move to the next question. Question number 27. The reduction potential of hydrogen half cell will be negative if. So it is given that the reduction potential value of hydrogen half cell will be negative, but at what condition? If what? So options are pH2, that is pressure of H2 is 1 atmosphere and H positive concentration is 2 molar. Pressure of H2 is 1 atmosphere and H positive concentration is 1 molar. Pressure of H2 is 2 atmosphere and H positive concentration is 1 molar, or pressure of H2 is 2 atmosphere and H positive concentration is 2 molar. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. So let's see the answer. So the correct answer is option C, that is pressure of H2 is equals to 2 atmosphere and the H positive concentration is 1 molar. So reduction hydrogen half cell is basically this: H positive at X molar concentration, platinum H2. Half cell reaction will be 2H positive plus 2 electron giving us H2 molecule. So if we want to find out the reaction quotient, which we use in the Nernst equation later, is equals to P of pressure of H2 divided by the concentration of H positive whole square, because 2 is the stoichiometric coefficient in the reaction for H positive. N is 2, you can see here. So we just write the Nernst equation value, which is E of reduction is equals to E naught of reduction minus 0.0591 divided by N log Q. E naught of reduction for the hydrogen half cell or for the hydrogen electrode will be 0, and it will be minus 0.0591 divided by 2, N is 2 log Q. Okay, and now we just put the value. So and solve the this Q value for different pressure of H2 and H positive concentration values given in the option. So in option A, pressure is 1, H positive is 2 molar, so Q will be 1 upon 2 square, that is 1 by 4, that is 0.25. And E reduction will be positive for this. For the B option, pressure of H2 is 1 atmosphere, hydrogen positive concentration is 1 molar, so Q is coming out as 1 and E of reduction is 0 for this. Pressure of H2 is 2 atmosphere in the C option, H positive concentration is 1 molar, so Q will be 2. So E of reduction is coming out as negative. Pressure of H2 is 2 atmosphere in the D option and H positive concentration is 2 molar. So Q is coming out as 0.5 and E of reduction is coming out as positive. So what we have asked that the negative reduction potential of hydrogen half cell will be only if. So you can see that E of reduction is only negative in the C option when the pressure of hydrogen gas is 2 atmosphere. The concentration of H positive is 1 molar and Q is coming out as 2. That's why E of reduction is negative, and so it is happening only in the C option, right? So negative value is only present when the C option conditions will satisfy the Nernst equation. So pressure of H2 will become 2 atmosphere and H positive concentration will become equal to 1 molar. And thus option C is the correct answer. Okay. Now let's move to the next question. Question number 28. Which of the following statement is correct statement? So we have to select the correct statement among the given options. Options are E of cell, that is potential of cell, and del Rg of cell reaction, both are extensive properties. E of cell and del Rg of cell reaction, both are intensive properties. E of cell is an intensive property, while del Rg of a cell reaction is an extensive property. E of cell is an extensive property, while del Rg of cell reaction is an intensive property. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. Now let's see the correct answer, that is option C. So this is the correct statement among the given options, that is E of cell is an intensive property while del Rg of cell reaction is an extensive property. So basically E of cell is an intensive property because it does not depend on the system size or the amount of material in the system, while del Rg of a cell reaction is an extensive property because it depends on the amount of material in the system. So extensive properties are those which depends on the mass, and intensive properties are those which do not depend on the mass. E cell do not depend on the amount of material in the system, so that is why this is an intensive property. But del RG depends on the material of the system, amount of material in the system. So del RG is an extensive property, and as stated, this is stated in the option C, and thus option C is the correct statement, correct answer. Okay, let's move to the next question. Question number 29. The standard EMF of a cell involving one electron change is found to be 0.591 volt at 25 degrees Celsius. The equilibrium constant of reaction is 1 Faraday, value is given 96500 coulomb per mole. Options are 1 times 10 to the power 1, 10 to the power 5, 10 to the power 10, or 10 to the power 30. We have to find out the equilibrium constant. We have given the standard EMF of a cell, which is this much. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is 10 to the power 10. So relation between K equivalent, rate constant, equilibrium constant, and E naught of cell, standard EMF of cell. Because we have given the standard EMF, we have asked the equilibrium constant for the reaction. So the relation between these two is that E naught of cell is equals to 2.303 RT upon NF log K equivalent. So this is the relation between the equilibrium constant and standard EMF of a cell. So E naught of cell will be equal to 0.0591 because this is a constant value 2.303. R is a constant. T is given 25 degrees Celsius. We convert it into Kelvin, and which will also be constant. N is different, so we will see that later. F is also 96500. It is also constant. So we just put that value together and just solve this constant value, and it is coming out as 0.0591. So E naught of cell will become equal to 0.0591 divided by N log K equivalent. E naught of the cell, standard EMF of a cell is given in the question. So 0.591 is equals to 0.0591 divided by N. N is 1 because it is also given in the question that one electron change is having in the reaction. So N will be 1 log K equivalent, and we have to find out the equilibrium constant, and this is the only variable present in this equation. Therefore, we just solve it, and the log K equivalent will become equal to 10. So K equivalent will become equal to 10 to the power 10. We just reach from this equation to this equation by using the log characteristic log formula, that log base 10, K equivalent is equals to 10. So K equivalent will become equal to, this 10 in the base will go here, so 10 to the power 10. Okay, thus the K value is 1 times 10 to the power 10, and thus option C is the correct answer. Okay, now let's see the next question. Question number 30. Given below are the half cell reactions. Mn2 positive plus 2 electron giving us Mn. E naught will be minus 1.18 electron volt for this. And twice of Mn3 positive plus electron giving us Mn2 positive. E naught will be 1.51 electron volt for this. The E naught for this reaction, 3 Mn2 positive giving us Mn plus 2 Mn3 positive. So we have to find out the E naught for this reaction. We have given the E naught for these two equations. Options are minus 2.69 volt, the reaction will not occur. Minus 2.69 volt, the reaction will occur. Minus 0.33 volt, the reaction will not occur. Or minus 0.33 volt, the reaction will occur. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. So the correct answer is option A, that is minus 2.69 volt, and the reaction will not occur. So basically, this is the reaction for which we have asked the E naught value, Mn2 positive going to Mn plus Mn3 positive. You can see the oxidation number of Mn in the reactant side is +2. It is going to the 0 also, which is a reduction process. It is going to +3 also, which is an oxidation process. So oxidation and reduction both are happening. So Mn2 positive is oxidized as well as reduced. We can say that, right? Thus, it is a disproportionation reaction. And how we get it from the given two reactions? So first reaction, we multiply it by 2. So Mn2 positive giving us Mn3 positive plus electron, and we multiply it by 2. We basically reverse the second reaction here. In here, we reverse the second reaction given in the question. Okay, so Mn2 positive come at reactant side and Mn3 positive plus electron come at product side, and we multiply it by 2. So E naught will also get reversed. So minus sign will be as in the initial reaction it is positive. So in the final reaction it will be negative. Now the Mn positive plus 2 electron giving us Mn is same, E naught, which is minus 1.18 volt. Now what we do, we just add it. So it will be 3 Mn positive giving us 2 Mn3 positive plus Mn, and E naught is coming out as minus 2.69 volt. And since you can see that E naught is less than 0, so basically if you see the del G will be minus del G will be minus NFE, right? So del G will be negative when reaction is spontaneous, and for reaction to be spontaneous, del G should be negative. So if del G have to be negative, E should be positive in the reaction, because negative sign is already present in the G equation, right? So E should be positive, but here E is negative, and that's why the reaction will not occur by itself. Okay, thus option A is the correct answer. Okay, let's see the next question. Question number 31. The standards reduction potential for zinc 2 positive zinc, Na2 positive nickel, and Fe2 positive Fe are minus 0.76, minus 0.23, and minus 0.44 volt respectively. The reaction X plus Y2 positive giving us X2 positive plus Y will be spontaneous when? Options are X is nickel, Y is iron, X is nickel, Y is zinc, X is iron, Y is zinc, X is zinc, Y is nickel. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option D, that is X is zinc and Y is nickel. So a cell reaction is spontaneous if the delta G naught is negative. And since delta G naught is equals to minus NFE naught cell, right? So for the delta G naught should be negative, E should be positive, right? If E will be negative, negative will become positive and del G will become positive. But E should be positive so that this negative sign will be there and del G will be negative automatically. So E naught cell is equals to E naught of oxidation plus E naught of reduction. So now let's do it. So for the option A, X is nickel and Y is iron. Let's put it in the equation. Nickel plus Fe2 positive giving us nickel 2 positive plus iron. So E naught for the nickel and nickel 2 positive is 0.23 volt. E naught for Fe2 positive to Fe is minus 0.44 volt. And thus the E naught of cell, if we calculate, it will be oxidation plus reduction. So this plus this, it is 0.23 volt minus 0.44 volt, because it is in minus initially. We just subtract it and it is coming out as minus 0.21 volt. So in this case, in the option A, E naught cell is coming out as negative, which should not be the correct one, because E naught cell should have to be positive. So this will not be the answer. Let's see the another options. In the option B, it is given that if X is nickel, Y is zinc. So nickel plus zinc 2 positive, giving us nickel 2 positive plus zinc. And the E naught for the nickel to nickel 2 positive is 0.23. Then E naught for zinc 2 positive to zinc is given as minus 0.76. So E naught of cell will become this plus this, that is 0.53 in negative. You can see that E naught for cell in this case also it is negative, which should not be there. In the C option, it is given that if X is iron, Y is zinc. Again, let's write the reaction. Iron plus zinc 2 positive, giving us Fe2 positive plus zinc. So we just putting the X and Y values in the initial reaction given in the question in the X and Y form. Okay. And E naught is given also, so we just counting that, we're just writing that. So E naught of Fe and Fe2 positive is 0.44 volt. E naught of zinc 2 positive and zinc is minus 76 volt. So if we find out the E naught of cell, it will be cathode plus anode. So E naught of cathode is 0.44 minus E naught of cathode is 0.76. So plus minus will become minus. And we have to subtract them. So it is minus 0.32. Here also you can see E naught of cell is coming out as negative. It should not be negative, it should be positive. Again, I am reminding. So this is also not the correct answer. Let's move to the option D. In the option D, it is given that if X is equals to zinc and Y is equals to nickel. So reaction will become zinc plus nickel 2 positive to the zinc 2 positive plus nickel. So E naught for zinc to zinc positive is 0.76 volt. E naught for nickel 2 positive to nickel is minus 0.23 volt. So E naught of cell will become cathode plus anode. Cathode is 0.76 plus anode is minus 0.23. So it will be 0.76 minus 0.23. We have to subtract them. It is 0.54 in positive sign. So here finally we have got the E naught value which is greater than 0, which is positive. And that's why this will be the spontaneous reaction. And thus the D option is the correct answer. That if X is zinc, Y is nickel, then this reaction will be spontaneous. Okay, so D option is the correct answer for this question. Okay. Yeah. Thank you.